Hello, this is a talk for the poster for the project for the module CS221. Here we consider explainability of feed-forward neural network models. Neural networks are gaining popularity in a variety of applications, including quantitative finance. However, due to this model's complexity, their predictions are often difficult to explain and validate. Simpler techniques, such as linear logistic regressions, are well understood and controlled by model developers and analysts. Neural networks, in contrast, have many hidden layers and neurons, the exact roles of which are not easily understood by humans. The primary focus of this project is to examine the feasibility of several methods in interpreting and explaining decisions made by credit default risk neutral based models in the context of credit card portfolio. The social impact of human interpretability in credit risk estimation is very important. The customers have a fundamental right to be fairly treated. This means that any lender's decision on a credit application must be explainable. This applies to rejection and acceptance decisions alike. In the first case, the customer has the right to know if any discrimination based on ethnicity, gender, and so on took place. Whilst in the second case, the customer should be reassured that the bank did not blindly accept a credit application that is likely to end up in heavy financial distress of the applicant, the so-called concept of credit affordability. For the dataset and features, for this project, a publicly available dataset is used. This data provides information on default payments, demographic factors, credit data, history of payment, and bill statements of credit card clients in Taiwan from April 2005 to September 2005. The input used for the project has 23 features. There are 4 demographic features covering gender, education, marital status, and age of each client. They are followed by 18 features providing history of payment and bill statements, i.e. repayment status, as well as amount of bill statements and previous payments for the 6 consecutive months. The last feature is the amount of credit given to the client. The ground truth or the true label output takes 2 values, 0 for no default and 1 if the client defaults on the next month's payment. It is worth noting that dataset contains some non-economic features such as gender, education, and marital status. Whilst nearly all legislations ban the use of sensitive variables for credit assessment scoring models, including this for training of the models in this project can allow us to investigate the reliance of the models on these features, their impact on performance metrics, and the potential power of neural network interpretation techniques and validation of these models. Moving on to the models, the neural network examined here is a feed-forward neural network, and we also consider 2 benchmark models. These are the logistic regression model and random forest classifier. For the feed-forward neural network, we have 3 hidden layers with all activations are early, apart from the last one, which is sigmoid, and we use dropout to prevent overfitting. Random forest here generates many individual decision trees, and for each tree the number of variables considered at each split is limited to a random subset. The results, so all models in scope are trained and tested on the respective datasets, training and test. Some results, various performance metrics are provided in table 1, where the numbers in bold represent the highest values of the metric. So we can see there's no single model that outperforms the others for all the metrics, but the neural network is doing pretty well. Now we move on to the analysis and explainability. The first method we consider is the relevance. The most cited relevance analysis technique applied to deep learning models is the layer-wise relevance propagation method. It makes use of deep tailored decomposition, and the aim of this approach is to assign a relevance measure to each input feature of the neural network, and in turn this represents direct contribution of each feature to the final outcome of the neural network. The framework has been modified and adapted and used to obtain relevance for the feed-forward neural network and the logistic regression models. Feature importance for these models is based on the percentage contributions to the sigmoid score. For the random forest classifier model, ranks features according to how much Each feature discredits the weighted impurity in the decision tree, which in turn average across all the decision trees in the model. The feature importance for these three models is captured in figure.
Hello, this
one.
is
Since these values add up to one,
for
it
project
allows a straightforward
CS221
comparison across models.
Okay.
We can focus on three metrics summarized in the table 2. These are the ranking of the features, the variation within the features, and utilization of the features. So firstly, it can be observed that the payment status, or the pay 1, this is a variable for 1 month preceding the analysis date, is in the top 3 important features for all 3 models. And the credit limit amount, labeled limit balance, is in the top 3 features for both the neural network and the random forest classifier. This makes intuitive sense. Recent credit events play a very important role in the future short-term behavior, and credit limit amounts are to some extent a direct proxy for credit assessment by other lenders. However, unlike the neural network, gender is the most important feature for the logistic regression, and age is the second most important feature for the random forest classifier. Further analysis is needed to determine the specific feature important difference is the main reason for the highest recall score in case of the random forest or the lowest recall score in case of the logistic regression. Nevertheless, feature importance indicates that model considers more relevant and more important, and in the case of the neural network, this technique shows us how to compute these values. Secondly, the variability of the importance across features based on the standard deviation for each model can be studied. Out of the 3 models, the neural network has the least, and logistic regression has the most variation. In particular, logistic regression highly relies on some features such as age, education, bill amount 6, and pay amount 3. It is worth noting that across model, some non-economic features are endowed with high relevance scores in relative terms, like gender, education, and marital status variables. Whilst nearly all legislations ban the use of these sensitive variables for credit assessment and scoring models, including these variables in the example shows the potential power of neural network interpretation techniques in model validation exercises. The next method we consider is the sensitivity analysis. So as in the previous section, relevance analysis provided a way to find the marginal contribution of each input feature to the output score. Sensitivity analysis examines which changes in the input feature the output is the most sensitive to. One way to analyze which input feature makes most impact on the final output is to examine occlusion sensitivity. This method has been widely utilized in image classification approaches. For this approach, different portions of the input image are systematically occluded with a gray square, and after the model is monitored. If a particular occlusion had caused network output to change dramatically, it will indicate the portion of the image was important for the classification. In this project, the occlusion sensitivity method is adapted for the credit card payment performance example. Here, instead of the gray square, each input feature is in turn replaced by the average in the dataset, and the corresponding output is generated. Resulting sigmoid scores, one for each feature changed, are then plotted in a heat map. These heat maps are provided for all 3 models. In case of a true negative on the default candidate, it can be observed that gender, marital status, and age are the most sensitive features, as well as education, while occlusion sensitivity analysis shows that neural network model penalizes, i.e. makes a default prediction based on the payment delays and the credit card bill amounts, logistic regression, and a random forest classifier in turn out to be slightly more punitive to candidates who are younger, female, or unmarried. For the next analysis, the profile analysis, if we consider modified unary quantitative input influence, which is defined as the difference between the original sigmoid score and the one resulting in the inclusion of a feature, then following approach in paper number 1, these differences could be used as a distance metric for clustering to identify profile groups in the model. So 3 main profile clusters for the neural network models are shown in figure 3. So, for example, one of the main clusters can be described by individuals who graduate school level educated women in their early 30s with a large limit balance, who have been paying their bill on time in the last 6 months. For this employers, marital status is not an important feature, indicating a mixture of married and single candidates. So in the conclusion, the goal was to show feasibility of these techniques and tools to interpret the outcomes of neural network. And interpretability techniques could be valuable in all banking sectors that might benefit from the use of neural network models. The hope is that after being largely restricted based on interpretability grounds, banks and financial institutions may finally be able to consider the development of neural network models on a much broader scale than before. Thank you very much.